59, same kind of thing that we've been doing the last few. So let's figure out where negative 135 degrees is. Well, negative 90 is right there, and then 45 more. So negative 135 degrees is right there. And if we mark that off, let's call that theta. So we're finding the sine of theta, cosine theta, tangent theta, as well as the other three, cosecant, secant, and cotangent. So we know that this is the one where you have negative, so negative radical 2 over 2 comma negative radical 2 over 2. That's the 45 degree angle from there. So there's your like a reference angle for you. So we know we're right there smack dab in the middle of the third quadrant. So we know that the sine is negative radical 2 over 2. Same with the cosine. We know the tangent, when sine and cosine are the same, is 1. Cosecant then, reciprocal of the sine. Secant, reciprocal of the cosine. And cotangent, positive 1. Tangent and cotangent are both positive in the third quadrant. Let me switch pages, pause this and switch pages. Well, finally, we get to problem number 117, and we are told that we have this ordered pair that corresponds to an angle on the unit circle. In the unit circle, the angle is, the point is on the unit circle, and we're supposed to find two positive angles two negative angles, 3 positive angles, and 2 negative angles that correspond to this point on the unit circle. So one positive angle would be this one right here. We're supposed to find this in radians? In radians, yeah. So this angle right here, if we remember our 30, 60, 90 right triangle, we go over 1/2 and up radical 3 over 2. So the 3 positive angles, 3 positives are, one of them would have to be pi over 3. So pi over 3. And then if we go all the way around again, so we go 2 pi, which is, if we're counting in pi over 3s, then we have 6 pi over 3, 7 pi over 3. So that's one more. And then we need one more. So 7 pi over 3. Let's count by pi over 3s. Let's do that. So if we count by pi over 3s, then we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if we go one more time around, we have 13 pi over 3. So that's my 3 positive angles in radians. Now, how could we kind of streamline that? Let's think about this for a second. If this is 6 pi over 3, then we go, okay, so every 2 pi, so it's 2 pi, which is 6 pi over 3, and then we could, every time we go one time around, we go 6 pi over 3s. And then another time around, 6 more pi over 3s. So we go 6 pi over 3, 6 more is 12 pi over 3. So here's another, this is a streamlined way to do this. 12 pi over 3, 18 pi over 3, and so on. You just keep adding 6. You don't have to keep counting by ones. You can count by 6 pi over 3, and you go one more for 7. Then you go 12 pi over 3, and one more for 13 pi over 3. So that would be another way to do that. And then we have 3 negatives. So 2 negatives. Keep doing that. So 2 negative angles, and let's use red for that. So if we go around this way, we can count by pi over 3s again. 1, 2, 3, 4. 1, 2, 3, 4, 5. So that angle right there is negative. It's 5 pi over 3s, but in the negative direction. So negative 5 pi over 3. And again, we go negative 6 pi over 3. So we're back to the beginning. And then we go 7, 8, 9, 10, 11. If we go one more, it would be at negative 12 pi over 3. So here we're at negative 11 pi over 3. So we also have one more negative angle. We could go around again. 12, 13, 14, 15, 16, 17, get that to 18. So that would be also negative 17 pi over 3 if we needed one more negative. So that's it.